Now that we're more comfortable with properties of logarithms, we're going to use those properties of logarithms to solve exponential and log equations. We're going to first start with exponential equations. So the general procedure for solving an exponential equation is the first thing you want to do is isolate the exponential part. That is the part that has your variable in the exponent. Once you isolate that, and it's all by itself on one side and everything else on the other, the next step is to write your exponential equation in log form. By doing this, you'll then be able to get that variable out of the exponent so that you can solve for it. Okay, so then you solve for the variable. And if you would like, you can check your answer using an approximate decimal value. Okay, so the first example, this 4 to the power of 3y is the exponential part. That is the part that has your variable in the exponent. So that is the first step. I want to get that 4 to the power of 3y by itself, which means I have to divide both sides by 64. So I'm going to divide both sides by 64. And that's going to give me 4 to the 3y by itself. And then when I take 16 over 64 and reduce it, I get 1/4. Okay, so now if you notice, I have the exponential part by itself. Once I get it by itself, then I'm going to put this in log form. Right now it's in exponential form. Let's make a note of that. This is exponential form. And we're now going to put it in log form. So I'm going to rewrite it. My base is 4, so I'm going to have log base 4 of 1/4, and my log is the exponent, so I set that equal to 3y. Then I finish solving for my exponent, I finished solving for the y by dividing both sides by 3. So my final answer is going to be log base 4 of 1/4 divided by 3. That's going to be my y value. Now I can put that in the calculator and get an approximate value. If you have that option on your calculator that you can do different kinds of bases, you can go to your math menu, put in base 4 and put in 1/4 for the log, and then take that answer and divide by 3. And that would give you a negative 1/3. And then you can use that decimal approximation, and this time it came out exact as negative 1/3. But if it came out to a decimal approximation, you can use that decimal approximation to plug back into the original equation and check your answer. Okay, second example. In this example, this one's a little bit tricky because I have 2 exponential parts. So in order to isolate the exponential, I have to combine those 2 exponential parts together. So what I'm going to do is I'm going to divide both sides by 4 to the power of negative 4x. So both sides, I'm going to divide by 4 to the negative 4x on both sides. Those cross off, and I'm left with 1 over 16 is equal to, and now I have to use my rules for exponents. When my bases are the same and I divide, I subtract my exponents. So I have x plus 2, and I'm subtracting a negative x. So I have x plus 2 plus x, which would give me 4 to the power of 2x plus 2. So what I have so far right now is 1 over 16 is equal to 4 to the power of 2x plus 2. Now I've got that exponential isolated. That's the base that has the variable in the exponent. And once I do that, my next step is to put it in log form. This is exponential form. And now I've got to put it in log form. Okay, so my base is 4, so I'm going to have log base 4 of 1 over 16, and that's going to be equal to my exponent, which is 2x plus 2. Now, to finish solving for x, I subtract 2 from both sides. And divide both sides by 2. So my final answer is going to be log base 4 of 1/16. Then I take that answer and subtract 2, and then I take that answer and divide by 2. So this is my exact answer. And then if I want to put it in a decimal approximation, I can put it in on my calculator. And then once I get that decimal approximation, I can also use that to plug it into my original equation and check to make sure that it works. Okay, example 3. I want to isolate my exponential. Here's my exponential part because it has the variable in the exponent. So I want to add 9 to both sides. So my exponential part is isolated. This is an exponential form. And now that I have it in exponential form, I want to put it in log form. My base is e, so this is going to be log base e of 39, and my exponent is a minus 7. So now to solve for a, I have to add 7 to both sides. So a is going to be log base e of 39, and then I take that answer and subtract 7. Now, because this is log base e, I could also write it as natural log with the ln symbol. Either way is fine. I want to make a comment here too. I'm going to purposely make a mistake, and I'm going to label it as a mistake by saying a does not equal. This is not equivalent to log of 32. These you cannot subtract. This is its own number, natural log of 39, and then you take natural log of 39 and subtract 7. That 7 is separate from the log. So make sure you're careful and don't combine things that shouldn't be combined. So I'm going to label, don't make this mistake. And so if we go back up and look, you might do that here too. Be careful. Don't combine these two right here. It's not log of 4 and then take 1 over 16, subtract 2, and include that in parentheses. The log base 4 of 1 over 16 is a separate number, and then you subtract 2. So just be careful of that. Okay, next example, here's my exponential part right here. It's the base with the exponent that has a variable in it. So I want to isolate that 10 to the x plus 3 first. So I'm going to add 7 to both sides, which would give me a negative 12. And then I'm going to divide both sides by negative 5. So now I'm left with 10 to the x plus 3 is equal to 12 over 5. So now I have my exponential part isolated. So this is an exponential form. So now I'm going to put it in log form. Okay, so my base is 10, so I have log base 10, 12 over 5, is equal to my exponent, which is x plus 3. And now to finish solving, I'm going to subtract 3 from both sides. So I have log base 10, and I don't have to put that 10 in there if I don't want to because it's common log, and if it's not there, we assume that it's 10 anyways. And I take log of 12 over 5 minus 3. And again, don't forget, don't combine these. These are separate. Log base 10 of 12 over 5 is a separate number, and then you subtract 3. Okay, next example is a special case. Notice that this is already isolated. My exponential is already isolated. So if I go to solve this, I'm going to put it in log form. So my base is 2. So I would have log base 2 of negative 4 is equal to x. X is my exponent, so that's what I set the log equal to. And this is a does not exist. Because remember, you can't take the log of a negative number. So there is no solution to this equation. And if we look at the graph of this and look to see where they intersect, you'll see that there's no intersection. 2 to the x is an exponential graph. 2 is my base, which is bigger than 1, so this is going to be increasing. So 2 to the x, just a rough sketch, is going to look like this. And then negative 4 comes down here, is my constant equation, y is equal to negative 4. These two equations never cross. It is impossible for them to ever be equivalent to each other, no matter what the value of x is. They never come together. Okay, and example 6, the very last example I'm going to show you for solving exponential equations, is this is an exponential equation that is in quadratic form. Remember, quadratic-like equation is when you have 3 terms, the last term is a constant, and this exponent is double this one. So this is a good way to refresh on older material. When we have a quadratic-like equation, we use substitution. So I'm going to let u squared be e to the 2b. So then to figure out what u is, I square root both sides. So I would get e to the b. And now I can substitute. So I can rewrite e to the 2b as u squared minus e to the b is u, minus 132 is equal to 0. So now I have it set up like it's a quadratic, and I can factor it or use quadratic formula, whichever one you prefer, and solve it as if it was a quadratic. So this one factors nicely. I can factor this as minus 12 plus 11. So u is going to be 12, and u is going to be negative 11. But we're not done. The question is asking us to solve for b. b is our variable here. So I have to go back and resubstitute for u. So we said u is equal to e to the b. So I'm going to replace u with e to the b. So I have e to the b is equal to 12, and e to the b is equal to negative 11. This mini equation here has no solution. It's impossible. It's the same situation as what we had in the previous example. There's no value of b that I would ever plug in that would give me negative 11. If I put this in log form, it would be log base e of negative 11 is equal to b. And this is a does not exist. You can't take the log of a negative number. However, when I isolate or when I solve this and put this in log form, I would have log of e of 12 is equal to b. And I could also write that, because it's base e, I could also write that as natural log of 12 is equal to b. So this is my only answer. And then, of course, if you want to plug it into your calculator and get a decimal approximation, you can do that so you can check your answer. But this is the exact answer. And then if you plug it in your calculator, you can get the approximate decimal value as well.